Today, we're going to dive into a science that connects literally everything. I mean, everything from the device you're watching this on to the most distant stars. We're talking about the chemistry of everything.
So, just for a second, look around you. I'm serious. What could the screen you're staring at, the air you're breathing, and a star millions of light years away possibly have in common? It sounds like a riddle with no answer, right?
Well, here's the thing. They all play by the exact same set of rules. And the science that defines what all that stuff is, what it does, and how it can change, well, that's chemistry.
So, let's start at the beginning and build our way up. What exactly is this science of everything we're talking about? Okay, so here's the formal textbook definition. But let's be real, what does that actually mean? In simple terms, chemistry is the study of stuff, what it's made of, how you stick it together, and, this is the cool part, how it changes. It's really the science of transformation.
Now, if you want to understand how things transform, you first have to figure out what they are in the first place. So let's kind of take apart the world around us, starting with the most basic idea of all.
And that idea is matter. It's a simple rule. If it has weight and it takes up space, it's matter. The chair you're on, the water you drink, it's all matter.
And you already know matter in its three most famous forms, right? You've got solids, where all the particles are kind of locked in tight. You have liquids, where they're still close, but they can slide past each other. And then you've got gases, where they're just flying all over the place. Pretty straightforward. But this is where it starts to get really interesting.
See, all matter in the universe gets sorted into two big buckets. Over on one side, you've got mixtures. Think of the air you're breathing. Its recipe can change a little bit from place to place. But on the other side, you've got pure substances, and their recipe is always the same, no exceptions. Salt is always salt, water is always H2O.
And we can break down those pure substances even further. Think of elements, like you see on the left, as the letters of the chemical alphabet. You know, like H for hydrogen, O for oxygen. Compounds, on the right, are the words you build with those letters. Put H and O together, and you get the word H2O, water.
And water is just the most amazing example of how this works. Get this. Hydrogen on its own is a super explosive gas. Oxygen is the gas that fire needs to burn. But when you combine them in that very specific 2-to-1 ratio, you get liquid water, the thing we use to put out fires. It's a brand new substance with totally different properties. That's the magic of compounds.
So, if elements combine to make brand new things, there must be rules, right? It can't be total chaos. And you'd be right. Turns out there are some fundamental, unbreakable laws that control the whole game.
And meet our first chemical detective, Antoine Lavoisier. This guy, through some unbelievably careful experiments back in the 1700s, figured out the first and maybe the most important rule of chemical change.
It's the law of conservation of mass. And what it means is, you can't just create stuff out of thin air, and you can't make it disappear into nothing. The total weight of everything you start a reaction with has to be the exact same total weight you end up with. Always, no exceptions.
Next up in our story is Joseph Proust. And this guy, he was totally obsessed with recipes. He would analyze the same compound from all different places. Some he found in nature, some he made in his lab. And he discovered something incredible.
He came up with what we called the law of definite proportions. It just means that water is always about 89% oxygen and 11% hydrogen by weight. It doesn't matter if that water came from an iceberg or a puddle, or if you made it in a lab in New Mexico. The recipe is fixed. It's a universal constant.
Okay, so we know matter is made of atoms, and we know they combine following these super strict rules. But that leads us to a huge, huge problem for any chemist.
And here's the problem. Atoms are just ridiculously, mind-bogglingly small, and there's an unimaginable number of them in even the smallest speck of anything. You can't just pick them up and count them one by one. It's impossible.
So how do they do it? How can you possibly follow a recipe that calls for 2 atoms of hydrogen and 1 atom of oxygen if you literally cannot count individual atoms?
The answer is one of the most clever ideas in all of science. It's called the mole. And don't worry, it's not the fuzzy animal. Just think of it like this. The word dozen means 12, right? Well, mole is just a word that means a number 2. You can call it the chemist's dozen. Except the number is just a little bit bigger than 12.
Yep, that much bigger. That's a 6, followed by a 0, a 2, and then 20 more zeros after that. It's a number so gigantic our brains can't really even picture it, but that is how many particles, atoms, molecules, whatever, are in one single mole of a substance.
And this slide, right here, this is the big reveal. This is the whole point. Look at those piles. They're all different substances. They have different weights, different colors, but each and every one of those piles contains exactly 1 mole of its stuff, which means every pile has the exact same number of particles inside it, that crazy huge number we just saw. The mole is the magic bridge that connects the tiny, invisible world of atoms to the world of grams we can actually weigh in a lab. It's what makes modern chemistry possible.
Which, brings us right back to the beginning. The Nobel Prize winner Roald Hoffmann said it perfectly. Chemistry is the science of molecules and their transformations.
We've figured out the rules. We've learned how to count the pieces. We understand this science that builds our entire world, from the medicines we take to the materials we build with. So, really, the only question left is, what are we going to transform next?